question says sum of first p terms of an arithmetic progression. Sum of first p terms, that is SP, is equal to the sum of first q terms. So sum of first p term is equal with sum of first q term. Then show that sum of first p plus q term is 0. So that we need to prove. So just keep this part reserved. Work on this. SP is equal with SQ. So this is given. This is a condition which is already given in our problem, that sum of first p term is equal with sum of first q terms. We know sum of first n terms is equal with n by 2 in n by 2 into bracket 2a plus n minus 1 into d. This is our formula for sum of first n term. Same formula we can use here for SP and SQ. Instead of n, we are going to take p and q respectively. So as per this given condition, this formula can be substituted over there. So SP will become p by 2, n by 2, that is p by 2 into bracket 2a plus n minus 1. So instead of n, I'll take p minus 1 into d is equal with SQ. SQ again q by 2 into bracket 2a plus n minus 1. So instead of n, I'll take q minus 1 into d. So we substitute like this, p by 2, here we have q by 2. Both the equations can be divided by 2, both the sides can be divided by 2. So you will left with p into bracket 2a plus p minus 1 into d. Here and here q into bracket 2a plus q minus 1 into d, like this. Correct? So we divide both the sides by 2. Now we can open the bracket. So when you open the bracket, this p will multiply with all the terms. Here we have two terms within the bracket, 2a p minus 1 into d. So these are two terms within the bracket. So when you open the bracket, the p will multiply with these two terms of the bracket. So these two terms can be written as 2 into ap plus p into bracket. This p is multiplying with this second term. So p minus 1 into d, like this. Same way on the other side, we have two terms again. These are two terms. You can multiply q with them. So it will become 2aq plus q into bracket q minus 1 into d, like this. Now after that, we can further simplify. this P can be multiplied with P as well as minus 1, and here we have D also. So this when you multiply P with D, it will become PD, and this PD will multiply it with P as well as minus 1. So finally this can be written as 2AP plus P into P into D. So this will become P square into D minus P into 1 into D. So this will give you PD, correct? Now on the other side, 2AQ plus Q into D. So this will give you Q square into D plus minus minus Q into 1 into D, that is QD, like this. Is it clear, everybody? Now on the right hand side, whatever values we have, we will bring them to the left hand side, and I'll equate them as 0. So here we have 2AP, right, plus P square D, then minus PD, and then we have minus this plus 2AQ will become minus 2AQ. Am I correct? This is plus Q square D, and when you bring it to the left hand side, it will become minus Q square D. This is minus QD, so when you bring it to the left hand side, it will become plus QD is equals to 0, because nothing is left on the right hand side. We brought everything from right hand side to left hand side. So you will get this expression. Now it's time to simplify this expression. So how we can simplify this expression? 2AP minus 2AQ can be paired together. 2AP minus 2AQ. So we will keep these two terms in one bracket, and plus we have P square D minus Q square D, right? These two terms can be paired together. Somebody annotating on my screen, please don't do that. Okay, so in second bracket we can take P square D minus Q square D, like this. And in last bracket I could take PD minus QD. Yeah, these two. So here I am taking minus as a common, this PD. So here we have PD. So this is plus QD, but since I am taking minus as a common factor, so this plus will become minus QD is equals to 0. So this way we can categorize them. Now what next? After categorizing them in two groups, we need to take out common factors. So what is common here? So I can see 2a as a common factor with both the terms. So I'll take out 2a as a common factor. So I'll left with p minus q plus. Here we have d as common factor. So I'll take out d as a common factor and I'll get p square minus q square. Again, here we have d as a common factor. So minus d will be taken out as a common factor and you will left with p minus q equals to 0. So we found d and 2a as a common factor. Uh, then further we can do one more thing. 2a into bracket p minus q plus d. Just focus on this part, p square minus q square. So it's like a square minus b square. And we know a square minus b square is equals to a plus b and a minus b. We can write it twice without square, once in plus, once in minus. So this can be written d into bracket p plus q into bracket p minus q, like this, minus d into bracket p minus q is equals to 0. So after that, again we need to take out common factors. After splitting this part, you can take out p minus q. I think p minus q is everywhere. So we can take out p minus q as a common factor, and whatever will left, you can merge them in one bracket. So here we have p minus q. So I'll take out p minus q as a common factor. In another bracket, we have 2a plus, we have taken out this p minus q. So after taking out p minus q, what is left? When you take out p minus q as a common factor, you will left with 2a plus d into p plus q minus d. So from this, we have d into bracket p plus q, and from this term we have only minus d. This p minus q, p minus q, p minus q is taken out as a common factor, and this is equals to 0. Now, after that, again I can take out d as a common factor from here. Look at this. This term has d as a common factor, and this term has d as a common factor. So here I can take p minus q into bracket 2a plus. So when you take out d as a common factor from here, you will left with p plus q. And from here, if you take out d as a common factor here, you will left with only minus 1 is equals to 0. Now, p minus q, question says p minus q, this I'm talking about this. This p minus q is not should not be 0. Why? Because question says p is not equal with 0. P is not equal with q. If two numbers are equal, then only their difference can be 0. But if two numbers are not equal, then their difference cannot be 0. Suppose p is 5, q is 5, so they are equal. So when you subtract them, you will get 0. But question already says that p is not equal with q, which means when you subtract q, any one of them from the other, the resulting number will not be 0. So here, according to this expression, p minus q into this equals to 0. If it is not 0, which means, look, if I am saying two numbers, that is a into b, these are two numbers, equals to 0. So what are the conditions? Either a is 0 or b is 0 or both of them are 0. Which means at least one of them is 0 or both of them are 0. Then only the product will be 0. Am I correct? If I am saying a into b equals to 0, so here actually I am trying to say that at least any one of a and b is 0. Any one of them at least equals to 0. Either a is 0 or b is 0 or both are 0. Then only you, when you multiply them, you will get 0. So same way, you can consider p minus q as a and this part as b. So any one of them is at least 0. But according to question, it is clear now p minus q is not 0. Why p minus q is not equals to 0? Because p and q are not equal. So if p and q are not equal, so here you will mention, but p minus p is not equal with q, therefore p minus q cannot be equals to 0. Their difference cannot be equals to 0. So it is clear that 2a plus d into bracket p plus q minus 1 is actually equals to 0. Am I correct? So here it is a, here this part is a and this part is b. So a into b equals to 0. So we infer that p minus q, that is a is not 0, which means b is 0. That is the reason a into b equals to 0. So here 2a plus d plus q minus 1 is equals to 0. So this we prove with the help of given information, and this can be considered as 1. Now next part of your question says, then show that the sum of its first p plus q term is 0. So let us see What is P, sum of first P plus Q terms? So sum of its first P plus Q term, sum of first P plus Q terms, that is S P plus Q, is equals to P plus Q upon 2 into bracket 2A plus n minus 1. N minus 1, that is P plus Q minus 1 into D. Immediately you can join me. There will be no gap. Okay. So this is P plus Q by 2. P plus Q by 2. And this whole part can be considered as 0 into 0. Look at this. 2A plus D into bracket P plus Q minus 1 is equals to 0. So from 1, this is from 1. So therefore, sum of first P plus Q terms is equals to P plus Q by 2 into 0. So when you multiply any number with 0, you will get 0. And that was the requirement. Question was about to prove that P plus Q term of this arithmetic progression is 0.